How to manipulate objects with a robot. Hello everyone, my name is Hortensia and I'm gonna present my work with the Robot Hand Navigator project, enhancing robot hand pose using Azure Connect and April tag tracking for object manipulation. Basically, the main objective for this project consists on grasp or manipulate objects with the hand of the robot, estimating the robot hand and target pose using visual markers and the Azure Kinect sensor. The hardware implemented for this project was the Azure Kinect SDK sensor, the TiagoRobot, and several visual markers. For the software, what we implemented was Docker with Ubuntu, Rosnoetic, and the April tag library. Also, 4 stages were developed for this methodology. The first stage consists on the improvement of the marker detection, then the robot hand pose estimation using the previous improvement of the marker detection, then the design of a controller to reach different target points, and finally, the object manipulation, basically designing a state machine to design the motion planning. I will explain those stages in the following slide. Visual marker detection improvement was made using the April tag cross grabber and the Azure Kinect cross driver. So basically with these tools, I am able to obtain pixels of each corner of each tag detected. So the position improvement was made by obtaining X, Y, and depth camera frame coordinated, making a partial reconstruction of the point cloud, using depth information of each corner and the intrinsic camera matrix values. For the orientation improvement, the rotation matrix is obtained by using the cross product between V1 and V2, which are vectors that are obtained from the X, Y, and Z camera frame coordinates from each tag. So basically, with this process, it's possible to have an improvement of the pose of each tag that is detected, but also it is needed to implement a low-pass filter for those cases in which the tag is not detected or in the case in which the detection of the tag is wrong. So this process gives a good accuracy and performance of the tag data. The next stage consists on the estimation of the robot hand pose. During this stage, a square was constructed around the hand. So according with which tag is detected, will be the orientation that the hand will have in the algorithm. If tag 5 is detected, the orientation will be the one that is shown on the image, but if tag 7 is detected, the orientation will change. This will allow us to make a good prediction of the robot hand position and orientation. On the other hand, the algorithm makes a tag prioritization. So if the tag 5 is detected, and also the tag 6 is detected, the algorithm will prioritize the tag 5 detection because it's the smallest ID. The next stage consists on the design of a control system, in which we have the desired pose and the current pose. The desired pose is the pose that came from the tag that is detected from the camera, and the current pose is the robot hand pose that was built by the square construction around the hand with different tags. Basically, the error is calculated by the use of a relative transformation matrix between the desired pose and the current pose. Also, using a gain, we can obtain the linear and angular velocity, which is sent to the robot, and after that, an integration is made with this velocity to the previous pose estimation of the hand. And for the feedback, to have a better accuracy of the prediction, a type of Kalman filter was implemented, which is the complementary filter, in which we use the current pose. In other words, is the real robot hand pose that came from the camera detection, and also the one that we calculated from the integration of the velocity, which allow us to obtain a better accuracy of the robot hand pose prediction. The last stage is the object manipulation, in which a state machine was designed for the motion planning, in which the hand starts in an initial position and it doesn't matter which position is it. the hand will be able always to achieve the first target, then the second target, and then another target point or another action. So basically in this case, as I show in the image, the robot hand will go to the first target. This first target was designed to avoid some collisions that could occur if the hand is in another position. So this first target was designed to avoid collisions, and then the second target was designed to reach the object. So in this case, I show the example of how the hand can open the drawer. So basically, it consists on different target points in which the hand will be able to reach the drawer, and after reach the drawer, the hand will be able to manipulate the object to grasp the drawer and open the drawer. So basically, with different state machines, we can manipulate different kind of objects as we do it in the experiments. So I will show the experiments and simulations made in each stage. During the first stage, these were the results. We show a video before the improvement process in which the accuracy of data is really slow. And after the improvement process, the accuracy is really fast. So the improvement was really good after applying this improvement process for the position and orientation of each tag. During the second stage, robot hand pose simulation, the orientation and position will change according to the tag that is detected with the camera. So according with which tag is detected, it will be the orientation and position that the hand will have. And we can see in this video the orientation and position that the algorithm gave to the robot hand according with the tag that is detected. The experiment for the controller stage consists on test the controller on the TiagoRobot. So first of all, the position controller was implemented on the Tiago. The hand of the robot is able to reach the final target point after implemented the controller of the position. So we can see that the robot starts on an initial position, and then after the controller, the robot reaches the exact position that the target has. Also, with the orientation experiment, we can see in the V side that the orientation of the hand is similar to the orientation of the target. But if we move the target orientation, then the robot will be able to reach this orientation as same as the position.